This video, we are going to be looking at how to apply long division in partial fractions. So if you were asked to integrate this problem, they won't tell you to use long division. They will just say perhaps integrate this using partial fractions, or they will just say integrate this. But first of all, you need to know that in order to apply partial fractions, the degree of the denominator should always be higher than the degree of the numerator. What we are trying to say is that on the denominator, the highest power should always be bigger than the highest power on the numerator. So in this problem, we can see that we have x to the power 5 on the numerator, which is greater than x to the power 2. So we need to reduce that by long division. How do we apply that? We take the numerator and place it inside the long division, and then therefore we'll take the denominator outside, then the numerator will be inside this. So from here we want to reduce this x to the power 5 so that we can divide that x to the power 2 minus 1. So x, we'd say x to the power 5 divided by x to the power 2, we get x to the power 3. Then from here we take x to the power 3 and multiply by x to the power 2, then we get x to the power 5. We take x to the power 3 again and multiply by -1, we get negative x to the power 3. Then from here we subtract. When we subtract, we get that x to the power 5 will go out, then we'll be left with x to the power 3 because we have a negative inside the bracket. Then we will drop 2x down, negative 2x actually. So we can see that we are having x to the power 3 minus 2x, which is still higher than x to the power 2. So we reduce it again. X to the power 3 divided by x to the power 2. Now we get x. We take x as we did initially. We take x and multiply by x to the power 2. We get x to the power 3. We take x, multiply by -1. We get negative x. Then when we subtract now, this is gone. Then we'll be left, when we take negative 2x minus x, it's going to be -1. When we subtract this, if we do this, x, 2x minus the answer will be negative x. That's how we got there. So from here we can see that now we have a lower power. What we need to do is to take this. We don't get rid of those. Now we have to write them, x to the power 3 plus x. So now is the one that we have reduced. So now the power is no longer x to the power 5. It is in that way. Then we'll have x to the power 2 minus 1. And we shouldn't forget that we were integrating. And then, but however, before we go there, we can apply partial fraction to this now. We can see that this we can integrate by natural log, but let's do it by partial fraction so that we can see how it works. So if we are having negative x over x squared, remember, mind you, I'm only taking this out now. For now, it's going to give me negative x over x plus 1, x minus 1. Then this, I can write it in terms of partial fractions. Then it's going to be a over x plus 1 plus b over x minus 1. Then from here we can multiply by the denominator of the left hand side, where we'll get negative x is equal to a into x minus 1 plus b into x plus 1. So now we need to find the values of a and b. We can do that by firstly letting our x to be 1. If we let x to be 1, wherever we see x, we place 1 in our equation. Then on a, we can see that x minus 1 will give us 0, because 1 minus 1 is 0. Then this side we will have 2b. Then solving this will give us b is equal to negative 1 over 2. Then secondly, we can let x to be negative 1 from this equation again. If we have negative, we put x, we put negative 1 where it is x. Then on a, when we put negative 1 where there is a there, when we put negative 1 on the x, we'll get negative 2. Then on the side of b, we'll get a 0, because negative 1 plus 1 is 0. Then solving this equation will give us that a is also negative 1 over 2. So let's proceed. Now we have found the values of a and b. So meaning that we can write our expression as follows. So this one we have changed it and we have solved it. So then let's see. Then we have said that it's actually plus, it's going to be a plus a plus 1, then b this is what we should do from here. And then we have found the values of a and b. Plus x plus, so here we are having negative 1 over 2 x plus 1 plus negative 1 over 2 x minus 1. Then from here, this we can rewrite it in a nice form so that it's actually 1 over 2 x plus 1 minus 1 over 2 x minus 1. It's still the same thing. The negative signs, they affect the positive signs there. So we can integrate now. X to the power 3. We should always put the x when we're integrating. Plus x dx. So 1 over 2, we can take it outside the integral. Then we'll have dx over x plus 1. We take it outside the integral again, we'll have dx over x minus 1. So from here, when we integrate x to the power 3, we get that it is actually x to the power 4 over 4. When we integrate x, we get that it is actually x to the power 2 over 2. When we integrate this term here, we will get that it's actually 1 over 2 ln of x plus 1 minus 1 over 2 ln of x minus 1 plus c. Every time we should always include the c when we're integrating. So from here we can leave it like that. We can simplify this if you want. Then we end up having x to the power 4, and actually you should simplify, because most questions will say leave your answers in their simplest form. So we can have, actually, if we factor out negative 1 over 2, we end up having ln of x plus 1 and x minus 1 in that way. Then x to the power 4 over 4 plus x squared over 2. And then from here we will have ln of x squared minus 1. So this is the answer. And what we need to notice is that this term here, this one can be integrated directly by using ln, and then, but it depends on the type of question, if they are saying use partial fraction or if they just say integrate. If they say integrate, it's advisable that we can just integrate it directly, because you will just use the ln, which says that if you are having an integral of f prime x over f of x, you're just going to get ln f of x plus c. So from here, we can see that our f of x is actually x squared minus 1, and our f prime x is 2x. So we can see that we can take out the negative outside the integral and compensate with the 2, because we don't get 2, the 2 is not there. So we can compensate that by putting the 2. Then because we compensated with the 2, we can also divide outside the integral by 2 dx. Then this we can apply natural log formula, which is going to be ln of x squared minus 1 plus c. And then here we should write our plus c as well, even here plus c. And we can see that this takes us back exactly here. But here we just wanted to carry on with the partial fraction. Thank you for tuning in. Please like this video and subscribe so that you can stay tuned for the next content. Until next time, thank you.